Hello.
Hello.
Okay, so today we'll finish this, at least this part of real analysis infinite series part. We have to do a few theorems which will be useful for you in testing your convergence divergence of infinite series. And once that is done, we'll look at some questions.
Okay.
So the first one is this. It says let summation un and summation vn be two positive term series such that one Vn is convergent. Vn is convergent, and two, there exists m belonging to natural numbers such that for all n greater than equal to m, we have un plus 1 by un is less than equal to vn plus 1 by vn. Then we can say that summation un is also convergent. So what is the theorem saying? It says that suppose we have two different infinite series in which one of them Vn we know is convergent, and if there is some integer m, some natural number m, such that after m, for any n after the cutoff point m, you always have ratio of un plus 1 by un is less than the ratio for the corresponding convergent series vn plus 1 by vn. Then the un series is also convergent. So basically, vn series is like this. This is vn. It is convergent if there is some cutoff point m beyond which. Can you hear me?
Yes, sir.
There's some power cut, but the theorem that we are saying, have you understood what is the meaning? There are two series un, vn. This is convergent, right? If after some cutoff point m, so that n is greater than m, if un plus 1 by un is less than equal to vn plus 1 by vn, then un series is also convergent. Understood?
Yes, sir.
So that is going to be useful for us when we try certain questions. We'll see later. Uh, similarly, there is an opposite version of this, which is the theorem 2, which is for divergence, where we say let un vn be positive term series, and we know that this series is divergent. The second statement is if there is m such that for all n greater than m, we have un plus 1 by un is greater than or equal to vn plus 1 by vn. Then un diverges. For the converging theorem, what was necessary? The ratio of n plus 1th term to nth term was less than the ratio for the converging series, right?
Right.
For the diverging series, what has to happen? This ratio has to be greater than the ratio for the diverging series for all n which are greater than some cutoff point. This doesn't have to be true just at one point. It has to be true for every n beyond some cutoff point, right?
Right.
जस्ट कोई एक पॉइंट पे नहीं है, उसके एक कट ऑफ पॉइंट के बाद सारे टर्म्स के लिए ऐसा होना चाहिए.
ठीक है सर.
Then the series will diverge, or for theorem 1 the series will converge if the inequality is less than equal to, right?
Right.
Theorem 3 is called D'Alembert's test, D'Alembert's ratio test. So it says let un be a positive term series, be a positive term series such that first A is saying limit n tends to infinity un plus 1 by un is equal to 1. No, not 1, is equal to L. This is a positive term series. The ratio of this is equal to L. Now, what you can say is if L is less than 1, series converges. If L is greater than 1, diverges. Basically, if it is L tends to infinity, then also diverges, right? If L is equal to 1, we can't say anything. If L is equal to 1, can't say. It could be converging or diverging. Okay. In general, when the ratio of this is 1, we will have to, when we can't use this theorem to solve for convergence or divergence, we'll have to use other methods, like the methods that we discussed yesterday. We compare it with some known series, right?
Right.
So this theorem will be useful in cases when the limit is finite, less than 1, greater than 1, not when it is equal to 1. In that case, try other methods, right?
Okay, sir. Right.
So this is very important and also very useful because many times the limit might not be 1. So you can easily figure out by this theorem. Then the next one is called Cauchy's nth root test. That is theorem 4. Cauchy's nth root test. This says let un be a positive term series, be a positive term series, and let limit n tends to infinity un power 1 by n is equal to L. Nth root of un, right? Un power 1 by n is L, then we can say if L is less than 1, series converges. Again, L is greater than 1, diverges. L is equal to 1, can't say anything. Just like D'Alembert's ratio test, right?
Right.
The nth root test. So take the nth term, take power 1 by n, see the limit as n tends to infinity. If you have limit L is greater than or less than 1, then you can say something about it, right? Are you understanding? Now, these four theorems
Sir.
and the old stuff that we have learned about UN, VN and all, right? These things should be enough for you to test different kinds of situations and see if you're able
Right.
to figure out the convergence or not. Whatever was discussed in the previous classes plus these four theorems. Okay.
Okay.
So we'll look at some questions. So for example, to apply these concepts, for example, first question is this. Convergence of this series 2 factorial by 3 plus 3 factorial by 3 square plus 4 factorial by 3 cube, so on, till n plus 1 factorial by 3 power n. See all of those theorems and see which one will help you and try to figure out. Four theorems you have, right? Use D'Alembert's ratio test.
सर वही कर रहा हूँ. कट जाएगा. इसलिए कोई जाता. सर डाइवर्जेंस है.
L is coming greater than 1.
No sir. No sir. L is coming out to be infinite.
So then diverges, right? That is also, we had written that case also, no, in that theorem.
हाँ हाँ वही वाला लगा. L tends to infinity, then it diverges.
Okay, this one.
So converges are.
What is the limit coming?
Limit 2/3 आ रही है.
2 power n by 3 power n plus 1 plus 1 and 2 power n minus 1 by 3 power n plus 1. This becomes 2 and you can divide by 3 power n plus 1. So you get 2 1 by 3 plus 1 by 3 power n plus 1 by 1 plus 1 by 3 per n plus 1. So when n tends to infinity here, this is 0, this is 0, becomes 2 by 3, which is less than 1. So this converges.
Right.
Okay. Then find out what happens to this series 1 by 3 plus 1 into 2 by 3 into 5 plus 1 into 2 into 3 by 3 into 5 into 7, so on. Whether this series converges or diverges. You have to write the nth term, then you will be able to figure out.
सर n टर्म तो लिख दिया.
N plus 1 can all take the ratio.
बस. हाँ सर वो रेशियो ही ले रहा हूँ. बस होने वाला. हाफ आएगा सर वो लिमिट टू कन्वर्ट.
Limit is coming what?
हाफ.
So the series will converge, right?
Right. Right.
Look at this one. You have to find, you have to test the series 1 plus x squared by 2 plus x power 4 by 4 plus x power 6 by 6 and so on for convergence for all positive values of x. Basically, you have to figure out for which values of x it will converge or which values it will diverge. un is x power 2n by 2n,
Right.
right? Un plus 1 would be x power 2n plus 2 by 2n plus 2. Limit of n tends to infinity, un plus 1 by un would be x power 2n plus 2 by 2n plus 2, x power 2n by 2n. This becomes x square n by n plus 1, right? Limit n tends to infinity is x square into this becomes 1, is x square basically, right? When you do limit n tends to infinity here, you get x square. If x square is less than 1, the series should converge, right?
Right.
If x square is greater than 1, diverge.
Diverge.
So from 0 to 1, 0 is less than x is less than 1, series converges. For x greater than 1, we know for sure it diverges. The only thing we can't figure out from this test is what happens when x is equal to 1. In that special case, the test will not tell us anything, right? Because the test
So sir,
doesn't
वो
work
हो
for
जाएगा.
when limit is 1, test doesn't work. So you have to actually look at the series 1 plus 1 by 2 plus 1 by 4 plus 1 by 6 and so on. This is the actual series when x is equal to 1. And in this situation, you have to figure out what does this series do? Does it converge or does it diverge? Right? So remember last class stuff. How will you figure out whether this series converges and diverges? Last
सर ये
class we learned how to
हाँ
do this.
इसमें न्यूमैन लिख देते हैं हम.
Yeah? un is 1 by 2n, right?
हाँ we 1/2 and वो लिख देते हैं और
Compare
एक
it
नॉन
with
सीरीज से कंपेयर कर देते हैं.
vn, right? Right. Limit n tends to infinity, un by vn क्या आ रहा है? 1 by 2, which is finite.
सर वो हाफ आएगा. हाफ.
Finite is coming, and we
राइट
know
सर.
that this diverges. So this will also show same behavior. So this will also
हाँ
diverge.
वो डाइवर्स कर.
Basically, the point is that अभी तक सारे चीज जो पढ़ाया गया है, सारे चीज अगर तुमको याद है and you can use, then it will be fine. If you forget old class theory, then you will not be able to do this. Right?
राइट सर. सर एक चीज पूछनी थी, तो इससे प्रीवियस वाली स्लाइड में जा सकते हैं. यस सर. सर जैसे मैंने भी म्यू एन एक्स मतलब टू द पावर 2n अपॉन 2n लिया, तो सर इसमें n इक्वल टू 1 डाला, फिर 2 डाला, 3 डाला, तो x ये सारे टर्म्स तो आ जाएंगे, पर 1 कैसे आएगा? जैसे x स्क्वायर बाय 2 आ जाएगा, x टू द पावर 4 बाय 4 आ जाएगा, x टू द पावर 6 बाय 6 आ जाएगा.
That's fine. It is for n greater than equal to 1. First term is 1 and second term onwards the series is this.
तो हम फर्स्ट टर्म को इससे रिप्रेजेंट नहीं कर सकते ना, मतलब.
नहीं कर सकते. That's fine. First term is 1. After that, every term is following this pattern, so it's fine.
मतलब अच्छा अच्छा ऐसे लिख सकते हैं.
Have you understood how we decide for x is equal to 1 case?
हाँ सर वो तो समझ में आ.
X is less than 1 converges, x greater than 1 diverges, actually equal to 1 also diverges, right? For example, do this one. Suppose you have the series x by 1 into 2 plus x squared by 2 into 3 plus x cubed by 3 into 4 and so on for x greater than 0. Find out whether it converges and diverges and for what values of x.
Okay, sir. सर वो जो रेशियो आ रहा है वो x आ रहा है सर. हेलो सर.
हेलो हेलो,
सारी
क्या हो रहा है इसमें?
सर रेशियो x आ रहा है.
तो उससे क्या पता चल रहा है?
उससे सर x ग्रेटर देन 0 दे रखा है तो हम मतलब
When will the series converge? When will it diverge?
हाँ, जब x लेस देन 1 होगा तो फिर वो कन्वर्ज करेगा और x ग्रेटर देन 1 होगा तो डाइवर्ज करेगा.
और x equal to 1 में
x इक्वल टू 1 में हमें स्पेशल चेक करना पड़ेगा वो अलग से.
चेक करके बताओ फिर.
हाँ, सर बताओ. सर कन्वर्ज करेगा तब.
कैसे चेक किया?
सर सबसे पहले वो लिखा जब x इक्वल टू 1 डाला तो सीरीज हो जाएगा मतलब फिर न्यू n आएगा 1 अपॉन n इंटू n प्लस 1.
हम्म,
तो फिर vn लिया 1 अपॉन n स्क्वायर जो कि कन्वर्ज करता है.
हम्म.
फिर लिमिट n टेंड्स टू इंफिनिटी म्यू n बाय vn किया तो 1 आ रहा है.
Finite limit आ रहा है तो then you can say it will behave like the same thing.
हाँ तो फिर वो कन्वर्ज कर रहा है तो वो भी कन्वर्ज करेगा.
हाँ, okay. Then next one is this one. Summation n goes from 1 to infinity 1 plus 1 by n power minus n square. Test for convergence divergence. Which theorem will you use now?
सर Cauchy वाला Cauchy's nth root test.
Cauchy's root test is easier to apply here. In Cauchy's root test, you have to say that, okay, my un is this. I have to find out limit n tends to infinity, un power 1 by n, right?
Right.
So here it will become limit n tends to infinity, 1 plus 1
Tending
by
to 1 to
n
the power
power 1
tending to
plus n.
infinity का फॉर्म बना है. Tending to 1 to the power tending to infinity का फॉर्म.
This is what is coming. This will be 1 by 1 plus 1 by n power n, right?
Right, sir.
Correct.
Right, sir. 1 upon e आ जाएगा ये.
This is 1 by e.
Yes, sir.
The limit value is coming less than 1, right?
Right, sir.
So this converges.
Right.
Similarly, suppose you have this one, summation 1 plus nx power n by n power n.
Same चीज करेंगे सर इसमें. Cauchy's test.
फिर से Cauchy's nth root test से क्या आ रहा है इसमें?
X आएगा सर इसमें.
N tends to infinity, power 1 by n will come 1 plus nx by n, right?
Right. तो X आ जाएगा.
Coming as x. So if x is greater than 1, diverges. If x is less than 1, converges, right?
Right. X equal to
X
1
is
का करके देखना.
equal to 1 तो क्या आ रहा है? Series, right? The series x is equal to 1 में. One plus n by n whole power n, right?
Right.
Correct.
Correct, sir.
Basically 1 plus 1 by n power n is my un. So
3.
you can as n tends to infinity, right? This un is tending to e, right? This limit.
Yes, sir. तो diverge करेंगे.
So diverge करेगा क्यों? क्योंकि when you take the Sn, it will become very high, right? Because basically you are saying that when n is large, all the terms are getting closer to e, right? Right. समझ में आ रहा है क्यों डाइवर्ज करेगा? Sn is not bounded. Hello?
Yes, sir.
Because it is tending to a finite value which is not tending to 0 or anything, right? So you will not be able to find a bound for Sn. Therefore, it diverges for greater than equal to 1 series.
Right.
There are more tests, but you don't need to know all the tests. अभी जितना सीखा है उतना enough है. There are actually like several more tests, but don't think that will be applicable so much for you. Like whatever we have learned so far will be enough, I think. You need to revise everything that we have learned in sequences and series so far. Don't forget any of this. This is enough for your exam if there is a series question. But you need to revise all of the theory. We will come back to real analysis and do some of the more difficult topics later. But first, we will do matrices and determinants.
Okay, sir.
So matrices and determinants also will take around 7-8 classes to finish. After that, we will go back to real analysis and do whatever else is left. Okay.
Okay.
Okay, that's all for now. I'll see you then. Bye.
Okay, sir.